For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@mathsassignmenthelp.com, info@mathsassignmenthelp.com, or reach us at https://www.mathsassignmenthelp.com. 1. Give an example of a linear space over the rationals which is not a linear space over the rails. Can you find an example of a real linear space which is not a rational linear space? Explain your answer. Answer. The field Q is a linear space over Q, but not over R. In order to prove the latter statement by contradiction, suppose that Q is a linear space over R. For V equals 0, V is an element of Q, F G is an element of R, FV equals GV, F equals G, and FV equals GV, F equals G. This then would give a one-to-one map from R to Q defined as FFV. However, since the cardinality of R is greater than the cardinality of Q, there cannot be a one-to-one map from R to Q. Thus, by contradiction, Q is not a linear space over R. Conversely, one-to-one map from Q to R can be defined as QQR. Q is an element of Q, R is an element of R. Hence, by restricting the coefficients from R to Q, any linear space over R becomes a linear space over Q. mathsassignmenthelp.com. 2. Let A be the linear space of real infinite sequences, a 1, a 2, a 3, over R with coordinate-wise addition and multiplication by numbers. Which of the following are linear subspaces in A? A. Sequences with only finitely many non-zero terms. Answer. Yes, sequences with only finitely many non-zero elements are a subspace of A. Let S be all the infinite sequences over R with finitely many non-zero terms, and let A be is an element of S, K is an element of R. It is clear that A plus KB is an element of S since the number of non-zero terms will still be finite. B. Sequences with only finitely many zero terms. Answer. No, sequences with only finitely many zero terms are not a subspace of A. Let S be all the infinite sequences over R with only finitely many zero terms, and let A is an element of S. Since 0A equals 0 is an element of S, S is not a linear space. mathsassignmenthelp.com. C. Cauchy sequences, namely, AI. Infinity I equals 1 satisfying the following condition. For every epsilon there exists a number n greater than 0 such that n minus m epsilon for all m, n greater than n. Answer. Yes, Cauchy sequences are a subspace of A. Let S be the set of all Cauchy sequences and A be is an element of S. Suppose AB is given and choose epsilon A, epsilon B 0 such that AB equals epsilon A plus epsilon B. Find Na, NB is an element of R such that n minus m epsilon A for all m n Na, similarly for B. We need to locate NAB such that n plus bn minus m plus bm ab for all m n nab. From triangle inequality A plus B less than or equal to A max Na NB and minus m plus bn minus bm less than or equal to epsilon plus b. Hence, for nab equals A plus epsilon b equals ab. D. Sequences, AI, infinity for which the series infinity I converges. I equals 1 approve your answers. Answer. Yes, the sequences, for which the sum of the squares of the elements converges, is a subspace of A. Let S be the set of all the infinite sequences, AI, infinity I equals 1, AI is an element of R for which infinity 2 converges. Then, for I equals 1 AI 2A, B is an element of S, A plus B is an element of S, AI plus by 2 equals A plus B2 plus 2AB. By 2 2 I Cauchy-Schwarz 11 E greater than or equal to AB 2. Also, for K is an element of R, Ka is an element of 2S, Chi 2 equals K2AI. Therefore, S is a linear space. mathsassignmenthelp.com